Hello everyone, welcome back to another video on my YouTube channel. Today we are looking at a question called longest substring without repeating characters, and this question is also a part of the blind 75 list of problems. Let's go through the question first. So we are given a string S and we are supposed to find the length of the longest substring without repeating characters. So for example, if we see the first example here we can see that the longest string without any repeating characters is ABC, or this ABC, or we can even take that as BCA or CAB. All these are the longest length substrings without repeating characters. And we don't need to give the specific substring as the answer. We just need to return the length. So all of these substrings have length 3. So I just return 3 as the answer. We are given that the length of the input string is 5 into 10 raised to power 4, and it contains English letters, digits, symbols, and spaces. Now the most straightforward way I can see of solving this problem is the brute force approach. That is, first let's find all the substrings in this input string, and from those substrings find those which have no repeating characters, and then find the max length of those. So for the substrings, what I would do is start from A, take A as the only substring, then AB, then ABC, then ABCA, and so on. And for that, the time complexity would be n square, because I'll have two loops, one I and one j, which will be, I will be from 0 to n and j will be from I plus 1 to n. So this will give me all the substrings, but after that I'll have to do some checking that if any character is repeating in that substring or not. So for example, if this is the substring that I have and I have to check if any character is repeating, I can do that using a hash set. So that I can do in O of one time, but still I have to iterate this whole string. So that will be O of n inside the n square. So overall time complexity in this case would be O of n cube. And once we have that no characters in that substring are repeating, then we can just calculate a max here and just return the max at the end. Also, what would be the space complexity here? As we are using a set here to find if there are any duplicate characters or not, so that would be O of n, because n will be the max. Now, can we improve this time complexity somehow? Yes, we can. Let's see how we'll do that. Now, a better way to solve this problem would be to use something called a sliding window concept. So what we do in that is take two numbers I and j that define the current ends of a sliding window. So for example, let that be 0, 0 initially. So initially I'll have this as the sliding window, and I keep on moving the right side of the sliding window. So that is j. So first I'll move it to here. AB is the current sliding window, then ABC. And I keep on increasing j until I get a sliding window where there is a repeating character. So when I reach here, I'll notice that A is repeating now. So once I get A is repeating, I'll change I such that the previous A is removed from the sliding window. So where do I need to change my I to? So I needs to become 1 now, because the previous position of I was 0. So this previous position I'll need to store, or I'll need to store the position I need to move to. So for that we can use a hash map. So let's take a hash map, and in this hash map I'll store the position I need to move to. So for example, if this is the sliding window currently, I'll notice that A has repeated and the position I need to move to is 1. So each character, I'll know when to move to when I encounter that character again. So let's start again from the beginning. So initially I have only A as the sliding window. So for A, I'll store 1 because if A repeats, I'll have to move I to the first index. And when the sliding window becomes this, I'll need to store B. So B will become 2, similarly C 3. And now when I reach here, I'll know that A is repeating because A is already there in the hash map. And then I'll change A to I to 1. So the new sliding window will become this, and A will get updated to 4. Now when I come to B, I know that B is also repeating now because B is there in this hash map. So again I'll move on, increase I to 2, and B value will get updated to 5. And similarly when I reach C, I know C is repeating now. So this will be the new substring, and C's value will get updated to 6. Same for B again, B is repeating. Now in this case, the I will become 5 and B's value in the hash map will get updated to 7. So now the current sliding window is CB. Now once I increase J again and take in this B as well, so I know that B is repeating, I will become 7 and J will also become 7. And once I increase J, this loop will end. Now in this process, I'll also find the max length of this window which we were calculating, and that will be our answer. Max window. And this will return as the answer. Now what would be the time complexity of this approach? It would be O of n. And what would be the space complexity? We are storing the indexes of each of the characters in the string, and we are given that this is a limited character set, so English letters, digits, and alphabets. So let's call this M. So in our case, space complexity will be O of minimum of M and N. Because if the input character space is very small, then M will be smaller than N. Now, one thing I missed explaining in the previous example was that what would happen if there is a character in the hash map and that is not in the present sliding window. So let's see this example, ABCD BSAKM. So in this, the answer should be CDBSAKM as the longest substring with no repeating characters. But let's hand simulate it first. So for example, if I reach this sliding window and I have the hash map for it, so A is, let me just write the indexes here, 3, 4, 5, 6, 7, 8. Okay, so A will be 1, B will be 2, C 3, and D 4. So this is the current hash map. And now when I increase the right end of the sliding window, I'll see that I'll check in the hash map, B is already present. So I should change to 2. So the new sliding window will become 2 to 4. So this. And B's value will get changed to 5. Now include S. Then we include S. S will become 6 here. Then we include A. Now once we have to check for A as well. So when we check A here, we'll notice that A is already present, but it is not a part of the current sliding window. As you can see, A we have already moved past. Now we need to ignore A because if we include this A, this B will also get included and the current window will become invalid. Okay, so the way to ignore this A in the hash map is don't move I backwards. Only I will move forwards. So what we can do is I is max of I comma m of s of j. So I get the value from the hash map for the jth string. For example, here it is s of j is a. So and m of a is 1. So max of what is I currently? It is 2. So max of 2 comma 1. So I will remain 2 in this case. So we don't move it backwards. So this step will be ignored, and the current sliding window will remain CDBSA, and then we'll keep on increasing J like this, and this will be our largest sliding window, and whose length is J minus I plus 1, which is 8 minus 2 plus 1, and which is 7, which is our answer. Now let's see how we'll code this solution. Now let's create the hash map that we discussed. So we have taken an unordered map of type current to store the index to which we will change I to, and I have also initialized I and j and created a loop for j until the end of the string. Now what we need to do is if the map has the current character, so s of j, so if this is not equal to m dot end, that means we found something in this hash map. So in that case, we'll just change I. So I will become max of the current value of I and the map's value of j. So that would be m of s of j. Okay, I'm changing I, and let's also create a max length. So int max length, initially I keep it to 0, and let's also change this max length at every step. So max length will become max of max length and the current length, which is j minus I plus 1. And we'll also need to put items into this hash map, so that I am missing right now. So that we will do after we are here. So once I've calculated the max length, then I'll insert it into the hash map. So m of set it to j plus 1, the index on which I want to move to in case it repeats. And at the end, just return the max length. Okay, creating a loop over j. If the character at jth place is already there, then change I accordingly so that it does not repeat in the current sliding window. Then calculate the max length and store the value for the jth character. Okay, let's try running it. Okay, if m dot find, m wrong, syntax is a little wrong, so m dot find s of j. Let's try running. Okay, so the test cases worked. Now let's try submitting it. So that worked. As you can see, our O of n solution worked perfectly fine. I hope you got it. If you didn't, feel free to leave some comments below so that I can answer those. Like, share and subscribe to this video, and do subscribe for more such future videos. Thank you for watching. Happy coding.